introduce a topic that I'm super passionate about, that maybe you have heard in the news, or like kind of like you have had some exposure and interest to getting to know a bit more about it. And the topic is blockchain. And half of this talk, we're going to talk about blockchain, and the other half, we're going to talk about like zero knowledge. Maybe the second part is a bit more abstract, a bit even newer. It's a bit more niche. But the goal is to just like introduce some concepts, some ideas, and hopefully as well for some of like people or colleagues that are also taking a master's program. You might also get some ideas about how this is used or could be used in the industry. What like useful applications exist right now, what type of things are being explored and discussed. And yeah, that you hopefully by the end of this talk, you can feel more motivated to keep learning about this topic, and hopefully some of you will be colleagues in this industry. What else? So, as an introduction about me, I'm Andy. My role, I work in this industry as a product owner in a team or a project called Ethereum Foundation. And my role is kind of like build tools that are useful for the ecosystem and for the people in general. And I'm also a student here in Oxford in Kellogg College, part of the Master of Science in software engineering. And yeah, hopefully we can like incentivize more people to do this so we can share more knowledge and in general learn more from each other. So the talk is more around like 30 to 45 minutes. Feel free to interrupt me, ask questions, or you can also wait until the end. We have until 6:30, and then we are going to be asked to leave the room for the next talk or event. So the title of this talk is A Newcomer's Exploration, Blockchain, Zero Knowledge, and Applications in the Industry. So let's get started with this first half. What is blockchain? You might have heard about it. You might have heard the term. Let's try to define it a little bit. I'm going to try to give some examples, like more formal definitions, and also some examples to create intuitions, because I know there's like different levels of knowledge and of interest within this room. So if I were to describe blockchain in a picture, is this. It's very simple. It's a chain made of blocks. What does they mean? What does this like try to reflect, and what properties does try to reflect? We can summarize it in one sentence. A blockchain is a decentralized and transparent ledger that securely records and verifies transactions across multiple computers. Okay, might sound convoluted, but make it really simple. A ledger is where you keep transactions and you keep a history of all the things that have happened, like I've sent you money, you have sent me money, etc. We keep this ledger digitally and we distribute that ledger. So it's not only a bank or one person or the head of Kellogg who has this ledger, but everybody in this room has this ledger. Not only that, but it's like it has other nice properties that we can start exploring right now. Now, if we expand this to a more complete definition, it has other interesting properties that we're going to start dissecting in this conversation, and also try to see why is this relevant. This invention, it's relevant. This ledger is shared in multiple computers, also called nodes, and we use some cryptographic algorithms and consensus mechanisms to make sure that the data can't be changed, so that can be modified, that is trusted by everyone, and where participants can interact directly with each other with no central authority or no intermediaries. So all across history, since basically this point in time, we have needed a third trusted party in order to make transactions, particularly financial transactions. We trust a central bank, we trust like the authority in the tribe. With these novel mechanisms, we have a way in which we can all make sure that nobody's cheating while still transacting directly, and we can all verify like our transactions, our history, and the rest of people's history in this digital ledger. Why do we say we use cryptographic algorithms? In this ledger, we are represented in something called an address. An address is basically a public key. An address says, hey, this is me, this is Andy, and you can send money to me. And what we do, every one of us, is like we can cryptographically verify, that's kind of like computationally verify that a transaction is valid with very simple or proven cryptographic mechanisms. This uses public and private keys and digital signature algorithms to basically verify that transactions are valid. So in short, every one of us can verify that all the transactions that have happened are valid, and we have access to that information. So what does this mean? Let me add a few more elements that are interesting, and then we'll see what repercussions this like new data structure, new way of organizing translates to. First, we've said is distributed ledgers. So it's not only one person who has this history or has this information, but it's like a network or a bunch of people or a bunch of machines. It's made of blocks and chains, and I'm going to explain why and where this name comes from. A block is the principal or first unit of information in these blockchains. And a block, what it contains is a history of all transactions. So imagine a box, a cardboard box, where I put there like all the transactions that have happened, and I seal it. I seal it with something called a hash, which basically is like a unique identifier. And the way they are constructed and why I cannot go back in time and change a transaction is that each new block that I add gets linked to the previous one. So basically with a unique identifier, I can make sure like this block not only contains all the information of the transactions that have happened in that block, but all the previous ones. So without getting too much into details, like this technique, it's called hashing or linked hashing. And what it basically does is like connects future, like any new transaction with all the previous ones that have existed in the past. So basically, if I want to cheat, I would not only have to change a hash, a value in passing the history, but that change will repercute in all the rest of the blocks. And I will have to change it in every node that exists in the network. So basically, cheating is really, really hard. I'll have to convince everyone to change the history, and that's basically impossible. We use public and private key cryptography. We use consensus mechanisms. So this is just a fancy word to say the mechanism or the way in which we all agree. So in most of blockchains, the consensus mechanism is what the majority says. So there's this premise that most people won't want to cheat because they want to see the system which they have value and they get value and they store value there, keep working, keep functioning. So in general, without entering too much details, there is an incentive for the network and the community to keep like being honest in this network. We've already talked about this. It's immutable and transparent. Transparent means I can see all the history that has happened since the beginning of a blockchain. And it's immutable because we say like in order to change one thing, I will have to change basically the whole thing for everyone. That's really, really hard. And some blockchains have an interesting property called smart contracts. So we're going to talk a little bit in the next one. But basically, a smart contract is a program and a way in which we can do similar things as like legal contracts that exist in the physical world, but on the digital world without any intermediary, any trusted party. Any questions so far? Every comment? Am I going too fast, too slow? All right. Trying to gauge like the like information background of the room. Okay, so what does this mean? So we have said that we have a new data structure, a new network with all these properties. What does this translate to? Like, what do we get from this? First, we get a system that is distributed. So instead of one central server, one building where it has all the information, and if it gets hacked, we're done, we have a system that is very resilient, that not only one person can just modify the values to hack someone, but you rather need to modify this value everywhere in the world to hack someone. So it's very, very hard or impossible. It's open, it's transparent, so you can see what's happening there. It's traceable. You can see where value, money, transactions, information has gone because you have access to this ledger. It's open source, so this community or public blockchains are open source. That means that anyone can see the code, anyone can contribute, anyone can run their own versions and their own nodes themselves. It's peer-to-peer. That means that there's individuals who connect to each other. So in here, everyone will connect to everyone instead of having a central person where everyone connects to. So that's like very much differences from the model of like central servers versus distributed peer-to-peer networks. And in censorship resistant. So this is a very important property, especially in this time in the world where, how to say this, like a party or a central server can dictate who can enter or who cannot enter the system. And sometimes it's very good and that's needed, but sometimes that also lends itself to favoritisms, cheating the system, and many other properties which are not great. So in summary, I will say that it's a system that it's, yeah, very open, transparent, traceable, resilient, and censorship resistance. Those are all properties that we might not get or likely don't get in more of like central systems, more like current modern systems. Okay, I'm gonna give two examples. Yes, let's stop in here.
Thanks, Andy.
Yeah.
So you say a property of this system of blockchain is that it's transparent.
Yeah.
What if I want to do something hidden? What do I do?
Yeah, it's a great question. So most blockchains, or at least the first generation of blockchains, are completely transparent, which is good because you can trace a lot of things, but it's bad for certain applications. Like I don't want, let's say, anybody to see my whole history of all the transactions and where I've been and all the payments that I've done. So you have to do a bit more things. Zero knowledge, which is the second part of the talk, helps some of this, but there are other methods. There are other blockchains which are not transparent, but right now I'm trying to like assume we're going to focus on the first generations, like most public. But yeah, it's a challenge, and I think it's one of the research areas that we have. Mm-hmm.
Sorry, related to that.
Yeah.
Like you say, it's designed for financial transactions, but my bank statement is confidential. So why doesn't I want everybody to see my transactions?
Correct. I think we do want that for accountability, traceability, and other things that we want to verify, but we don't want to see that in like your personal information, right?
When you say transaction, do you actually mean like with money, or can it be any kind of exchange of information?
It could be any kind of exchange of information. Yeah. So we could transact health data. We could transact representations of energy. We could transact tokens that represent something else, art or music or any type of thing. Really. Yeah. Yeah. But we're gonna continue. But we're gonna see like privacy. It's important. Oh, I remember what I was gonna say. These transactions are traceable to an address, but that address, we don't know who is behind that address. So these systems, to be more precise, are not anonymous. They are pseudonymous. Maybe you'll hear on the news, oh, like Bitcoin or Ethereum or whatever is like anonymous payments. No. The real definition is pseudonymous. We can always trace these transactions to an address, to something like a list of numbers really long, but we cannot trace easily that address to a person or an institution. Right? Maybe we do want to reveal that. Maybe we want Oxford or the Red Cross or this ministry to make public how they spend the money, and that's, I think, a fantastic use case. But maybe we don't want to reveal that. So yeah, it's great questions. We're going to continue. Hopefully, we can cover a bit more with certain help of some friends in technology. Okay, so two examples. Bitcoin. Bitcoin is actually the first blockchain or public blockchain. It's a convergence of, I would say, 80 years of a lot of different innovations in the field. And in 2008, 2009, it basically solved a combination of how do you get cryptographic systems which are secure, which distributed systems around the world, which some mechanism or incentives, economic incentives, so people want to continue to participate in this. And Bitcoin can be related to like digital gold. I think it's one of the best ways to make a parallel and understand it. Is digital gold that you cannot create out of the nothing, that you can send to other people, that you can store, but nobody can take it away from you if you keep your private key, which is like your secret or your password. If you keep that to yourself, nobody can take it away from you, and nobody can prevent you from using it or sending it. So this has caught a lot of attention of people who want to send transactions around the globe and maybe don't go through the financial system, because if you want to pay someone, I don't know, in China or I don't know in Philippines, it's really hard right now. Kind of like to get all the approvals, it's really cumbersome. But if you have access to systems like this, it's really digital and global native. So yeah, I think Bitcoin is a great example, like the first and by far the largest one, and it's already like trusted by countries and companies, and yeah, it's like 500 billion, like big. So it's like it's no longer like an experiment. It's already been around for like 14 years and continues to grow. Another great example, which I'm a bit biased, but that's where I work and I think it's fantastic, is Ethereum. It brings a new innovation called smart contracts, which we're gonna dive deeper into this. But basically, just to give an example or introduction, is like you can build programs that run globally. And you can do more complex things than just sending and receiving money or sending and receiving like little pieces of information like notes or text, but rather much more richer, complex interactions. Um, that's like the second biggest blockchain, and there's a huge list of other blockchains or tokens or projects that are part of this ecosystem. I would say like almost like 20,000 other blockchains, but some of them are fantastic. Like most of the ones that I've heard listed here are great projects. Like they continue to develop and bring innovation and solve real problems, but there are also a huge list of just scams and like bad actors and like just outright copy of innovations, which don't really like add value or try to even like support the properties and benefits that we've mentioned before: censorship resistance, decentralized, transparent, open source, etc. Yeah, cool. So let's enter a little bit into what are smart contracts. As the name suggested, it seems like a contract. It seems like something like an agreement that two people do or a bunch of people that can't be broken. The difference with the contracts and the legal contracts that exist, let's say on the legal system, is that these are done on the blockchain and it's just self-executing code. So imagine like a program that runs 24/7, that doesn't have bias, that doesn't have favorites or biases. You can program that on the blockchain, and you can already see that it has a lot of advantages to companies, individuals, institutions, countries, where they want to agree in a specific transaction, whether that be financial or other type of representation of transferring or interacting with information. You can see that these systems might be more neutral and more convenient for certain applications. We're going to dive deep into a little bit of the examples, but what are some advantages that I see or that we have been studied about smart contracts and why they are so revolutionary? Speed, efficiency, and accuracy. I've said that maybe getting how to say this, like a loan or get executed might take days, weeks, or even months in a legal contract in our legal system. With smart contracts, 30 seconds, 10 seconds, a block, I don't know, very quickly. It's globally available, it's always 24/7 running, etc. Efficiency as well. It's much quicker, much lot less resources and involvement, because again, if you want to execute a contract, you don't need 10, 20 people like pursuing people and like calling and like all this type of chasing. It's very accurate. So if it's a computer program, it will be deterministic. So it has the same input, it will always have the same output. Whereas in our human world, sometimes it's error prone. Again, sometimes there's biases. Maybe a judge or a jurisdiction will like, I don't know, differ in a contract. So those are characteristics that you get. You get trust. It's very transparent. You can see what is written and you can calculate how it will behave. So you can even like simulate how the code will behave. So there's no way of cheating if we all know exactly how the code will behave, which is not the same case with all the laws or all the contracts. And it's immutable. We cannot change it. Whereas in paper, maybe there's a new law and maybe that will change the whole interaction and the whole agreement that we used to have before. What are some challenges with these benefits? There are also challenges. It's permanent, so there's no way again to cheat it. We can always create a new one, and we can always stop using the old one and move to the new one. But then the old one will always remain, will always exist. There's the human factor still involved when creating the smart contract, and there can always be errors and loopholes and things similar to the, like laws, just the legal system. There can always be loopholes. Okay, so smart contracts maybe already have some idea about what they are, but we're gonna see some examples after seeing the challenge.
What did you say we're gonna?
See some examples.
Nice.
Yeah, I will mention just a few right now. An escrow. An escrow is a third-party person which is gonna facilitate a transaction between two people that don't necessarily trust each other. So I want to send you money and you need to send me an object, but maybe we don't know each other that much. We're gonna have a third person which we both trust, and you're gonna send the object, and I'm gonna send the money, and that person will make the swap. That happens a lot right now in like institutions, in companies, in like legal agreements. Maybe if it's all executed by code, we don't need that third person. Future derivatives. If the value of gas reaches this point, this person gets this money and this person doesn't. Right now, that happens like in banks and in like complex systems. With a smart contract, you don't need any of those infrastructure, any people, any trusted like third party. You just do it running on chain. Another example are loans. Like right now, we all save in a bank and or similar, and we all ask loans from the bank. So there's the intermediary. But what if we had a smart contract where you can save there, and other people can ask for loans, and then we interact without a trusted third party? Like the trusted third party is just code. So loans, escrows, futures like predictions, maybe I don't know, transferring even health data. Like we can make a program in which only if you pay me, I don't know, £1,000, you can access the information of this smart contract, which is basically my health data. Okay, so you start to see like there's like infinite amount of applications. We just have to get a bit creative about what we're creating. Cool. So yeah.
You said that you could like do the escrow. How do you submit a smart contract? Does that need to be some confirmation on both parties?
Yes.
It sounds like I could just say, yeah, you're going to pay me £1,000. You can't do anything about it.
Yeah.
Do they have to?
Yeah, that's a great question. So a smart contract exists. It's just like a law. Like exists there. It's an object, and if people want to interact with it, they would send transactions in a specific way. So basically, smart contracts are created not by lawyers, but by engineers who write smart contracts. It's basically like writing a program, and that program gets deployed on the blockchain, and people use it if they want to participate of that. So it's always opt-in. You are not forced to participate of any smart contract.
You have to interact with it.
If you wanna, yeah,
It's dormant until.
correct. Like we both agree we're gonna do that. We both interact with the smart contract, and I'm sorry. Yeah, great example. So in this case, I would imagine I have music, and I would upload a file or an equivalent, and if you want to buy it, you have to pay £10, and I will get it. Right? It's like a supermarket. That's a great analogy. There are many other constructions that we can do, but I think the key things to remember is like they are created by developers or engineers. They're called smart contract developers or Web3 developers. People participate opt-in, so nobody is forced to participate. Only if you want to interact, like in the real world, you interact by sending transactions or doing a bunch of other stuff. You had a question?
Yes.
Yeah.
Or no. So from that explanation, so that means if some smart contract will be activated for me, that means I have to explicitly kind of request something with it or use it or something. I can't design a smart contract that is based on some triggers.
You can actually, yes, define a smart contract based on triggers.
Okay, so by triggers, I mean, for example, some data chain in our function.
Yes, Yes, like if something happens on the blockchain, execute this. If something happens in the real world, execute this. But we'll see, that's a deeper problem. That's how you connect the real world with the blockchain. There are something called oracles. We're not going to talk about this in this call and this talk, but it's like definitely valuable to do that connection and have external triggers. Awesome. So this sounds fantastic. It's a great technology. We already can kind of like visualize a few use cases, but it has three. I'm just gonna briefly and pass over this three major challenges, and every blockchain has these major challenges. They are called the blockchain trilemma. You know, dilemma. You have to choose between two. In a trilemma, usually you have to pick two out of three, or you have to be very clever in how you overcome this. The goal of a blockchain, especially public blockchains, that they are decentralized. There's no single person controlling the information and the data and the value that we all have. And you want to achieve that. But you also want to achieve security, which is like nobody maliciously can, like a single person, try to modify the data or try to break down and take down the network. And it also needs to be scalable. We don't want to be paying it, we don't want it to be slow, expensive, etc. And that's a challenge because this runs on machines. And if a lot of people start using it, maybe those machines are not gonna be able to keep up with all the transactions. If you start asking for bigger machines or more powerful machines, you might be sacrificing decentralization, and only institutions and companies and countries can run those machines. Whereas if you want true decentralization, normal people like you and me can run those machines and keep the information. And lastly, like, yeah, you can be very decentralized with low machines, very scalable, but then you can be targeted of timing attacks and trying to take out the network with spam and DDoS and other type of attacks. So I think what I wanted to introduce with this slide is just like, this is a challenge. Different blockchains have different strategies on how to address this. And some of them do some, trade-offs just yes.
Can I ask, is there a way in which you can simply explain why all three criteria can't be employed?
Yes. Can be what?
Cannot be
Yeah.
all used at the same time.
Yes.
You mentioned 2 out of 3.
Yeah. They definitely can, and that's the goal of most, if not all, of the blockchains. They're trying to pursue this, but there's a challenge of trade-offs. So technically, if you want to be able to process more transactions, you need like a stronger machines, like more powerful, but they're more expensive. So you're sacrificing decentralization.
Would quantum computing help resolve that?
Actually, not, because how many people will be able to access and have one quantum computer at home, right? So again, you're kind of like sacrificing the decentralization aspect. Might be very secure, very scalable, but maybe there are only 5 computers and those 5 people control the network. We rather want the whole UK, the whole of the world, keeping the ledger, controlling, like making sure everybody else is behaving correctly.
Quantum computing is very easy to cheat the blockchain. You can change one bit and the others.
Yeah, I think if you've got a smaller network, it wouldn't be decentralized, would it? It would be a private
Exactly.
blockchain, so it would be used in a different way.
Exactly.
Decentralized system, it would have to be
Open,
multiple,
transparent. Yeah.
Nodes or computers.
Yes.
But that also relies on compatibility. Isn't that a major flaw?
What do you mean by that?
Well, I mean, it's possible for certain machines to look into the round of things. So, for example, you could interact a Mac with Windows.
No, it's not so much of a problem right now with compatibility. Like most of this just runs on the internet with certain packages and specifications. So it doesn't matter if you use Windows, Mac, Linux, or other future operating system. As long as you adhere to a specification, like you should be good. Yeah.
I mean, you can't put a DVD ROM in a VHS player. I just feel like things would actually specific before it actually solves the issue.
Yeah, we can talk more deeper like afterwards because I'm not getting your specific concern. But if I were to say like a general statement is like operating system is not a problem, compatibility is not a problem because what you run to participate in the network is a program which follows a set of specifications and rules.
And it's assuming that we're all on the same network.
Correct. Oh, I see. I see. Okay. Yes.
We are, we're all just using the internet. But
Great question. Great question. And maybe I didn't introduce this. Each blockchain is kind of like its own world. So Bitcoin blockchain has a ledger of all the Bitcoin addresses and can see how much Bitcoin each person has. But it doesn't see the rest of like the Ethereum blockchain or the Cardano blockchain. So it's like its own realm, its own reality. In that sense, yes, blockchains are not natively aware of the other blockchains. There are ways, there are called bridges, and that's a bit more complex, which maybe we won't cover here, in which you can move value from blockchain to blockchain. But yeah, it's almost like if you have dollars and you want to move it to pounds, that's kind of like one equivalent or analogy. Great questions. If like, hopefully we can have more time to go deeper into some of those details. Again, like it's hard to cover a lot. So these are just example applications that we might want to cover. This is a great website that I just discovered recently called thevalueprop.io. But actually, there are examples in every vertical industry that you can imagine. Marketing, education, finance, governance, like voting, security, social impact. To give some examples, and I'm gonna try to also open our minds in non-financial or like financial but not speculative use cases. What about KYC or land registry? I think it's a great use case. What if we had something to represent a home that I can transfer to you in the blockchain with a smart contract? Wouldn't that be a lot more efficient, a lot more traceable, a lot more evident that we're not cheating? What if I could raise money around the world because these systems are inherently international for a cause? And we're gonna see a few like real world examples where this has happened. What if we ask again, like I don't know, like Cancel to have a budget for infrastructure, and we all verify where the money was sent or where was it spent? Wouldn't that be great? What about payrolls, that we can do that directly everywhere in the world? What if we like verify that we're from a country without, I don't know. There's a bunch of other things. We can make smart contracts to make insurance. So instead of relying on one company, we all make a group of insurance with a smart contract, and we can there's a bunch of things like borrowing that we could do. Education, universal basic income. There are like a lot of projects and categories that are happening right now. So I'm gonna go a bit quick here. At the start of the war, I think like over $80 million were sent in a couple of days to Ukraine directly. I can't remember to which department. I think it's associated with NGO associated with the Department of Defense. Because it's really, really simple and cheap to send money internationally, and way, way easier to see where it was spent. In Argentina, the inflation is about 100% a year. So your money, basically, you can buy half of the things that you can buy last year if you store it in the local currency. So for many, this financial cryptocurrency aspect, the currency aspect, is very important for them to store value in dollars, in other digital currencies. In Canada, whether that was wrong or right, a group of truckers that were protesting about like certain COVID measures, they were completely taken out of the financial system and didn't have access to their bank accounts for, I think, months, without any court or judge order. So you can see like certain systems can be abused, and whether that was the right thing or the bad thing, for some people, they had to rely on external systems. MIT has a great project called MedRec on how your digital health data is stored on-chain, and you decide who you reveal this data to, and you can revoke permissions, you can do a bunch of things selectively. This is a great project called Quadratic Funding, where people vote for the best usage of community funds, and they vote by donating a specific amount, which is later matched or multiplied depending on that demand. So this has been great governance experiments in which we can find out what are the values and needs of a community by seeing how they interact and vote on chain. And then we support that and multiply the support for those causes. And even UNICEF and other UN institutions are participating, raising money, selling digital art, or raising money from other ways to support giving internet to children or other health related aspects. Um, Sweden is testing like a digital currency on-chain called e-krona. And there are some concerns or risks, but there are countries already like exploring, experimenting really interesting stuff. This was a hackathon which we supported, which basically is trying to fight counterfeit medicine and also confirm the logistics of medicine. If we can see the traceability about where it has been and all the stamps of approval is very good for supply and logistics and other things on telecom and other things, data privacy. So key takeaways of blockchain. Uh, for me, a good summary is like blockchain is distributed truth. We all know that something is truth and nobody tries to cheat on others or can't cheat. Smart contracts are unbreakable promises. It doesn't matter if you participate in their smart contract, it will execute regardless if you want it or not. There are some challenges, and we call this on a big umbrella the blockchain trilemma. And there are ways to solve them, and there are ways, technical innovations addressing them. But in general, it's like trade-offs that most projects have to do. And next part, we're going to talk about zero knowledge. It's a bit more niche, a cryptographic area, but many other techniques besides zero knowledge help address some of the challenges that we currently have with blockchain. How are we doing with time? This is we might not cover all of it, and probably we might want to have more conversations. So I'm just gonna do introduction of zero knowledge and see some examples, so we can have a bit more of a discussion. This also is a bit denser, I feel, but it's super interesting. At least I find it interesting. So zero knowledge proof, it's an area of cryptography which are methods or protocols that allows you one person called a prover to prove to somebody else called the verifier that a given statement is true. But what is fascinating about this cryptography protocol is that I am not revealing any additional information besides the fact that the statement is indeed true. So it sounds a bit like a tongue twister. How can I convince you that something is true without sharing any information?
Are you using that what a bank or a credit card already does?
Like, yes, for example, try to explain that a little bit more. But it's true.
If I come to you and I want to buy something and I give you my credit card and it's accepted, it's verified that it's the statement's true, I have the money to pay you.
Correct. In a way, you can see like like the parallel doesn't exactly use zero knowledge proofs, but it does use elliptic curve cryptography, and that's also part of the basis for constructing these things. And we have been studying a little bit more these days, but it's a great example and great intuition, actually, great intervention. I'm gonna do like more. Just like real world examples about how is it possible to convince you without sharing information. Let's imagine we're all competing to find Waldo. I think in here it's called different, right? Wally? Yeah, I found that was super funny to realize. Anyways, let's imagine we all have the same image and we need to find Wally. Let's say I find it. How do I convince every one of you that I did without revealing the answer so you can continue playing? So let's imagine I have a huge cardboard, or way bigger than the real image. I draw a little square in the middle, and then I position it so that I only show the face of Waldo, Wally, without revealing where exactly it is. So that's what these lines represent. You will be convinced that I did found it indeed, because you can see it there, but you won't know where exactly it is. And you can continue playing. So again, this is like an intuition about how I can convince you about something without revealing any additional information. I'm going to skip this example. What this does, yes?
Surely if you keep asking questions, you're going to narrow down the field where you're eventually going to say where it is.
Yeah.
Is there a point where you can refuse to answer it?
Yes. Zero knowledge, without entering too much into details, are divided into two big groups. One that are interactive, which you ask questions and you receive an answer, and more you get convinced. Actually, I think it would be good to see that example. And non-interactive, which is like this example. If I see Wally, like you found it, right? Like there's no more need to do back and forth. But let's do one example where there is back and forth. Let's imagine I'm a verifier and I have two pieces of paper, which because I'm colorblind or whatever reason, like I can only see them like the same color. But you, which are a prover, you can say those two pieces of paper are of different colors. So how do you convince me that they are indeed of different colors? So let's create this protocol, these steps, so you can convince me that that's happened. So I'm the verifier, and I have two pieces of paper. I don't know which one is, but I say, okay, I'm gonna pick one of them, and I know which one is, and I'm gonna try to shuffle it. So I decide which one of these is. I'm gonna show it to you, and I'm gonna shuffle them or not. Right? I'm gonna show them to you again. I know if I did shuffle them or if I didn't, but I don't know which. But they look the same to me. Now you are gonna try to say which one is the one that if I did shuffle it or not. So I show it to you, and you choose the right one, and then you say, yes, you did shuffle it. It's now here, and I say, oh yeah, yeah, you guessed it correctly, right? So there's basically a 50-50 chance. If you didn't know, if you couldn't distinguish the colors, there's basically a 50-50 chance to guess it right. So we repeat the exercise again. For me, they are the same color. It's impossible that you can guess it. But for you, it's really easy. I show it to you again, and you say, oh no, you shifted again. It's now here. So it's like, oh, you guess it correctly 2 times in a row. So basically, what this does is like the first time you had a 50% chance to guess it correctly. The second time that you guess it correctly again, you now had a 25% chance to guess it correctly twice if you're just guessing. So at the end, I'm almost convinced, because you have guessed it correctly 10 times, that you actually know an information that I don't know, which is the difference of colors here. So intuitively, what I'm trying to say with this is there are ways in which we in the real world prove to somebody that something is true without revealing any type of additional information, without telling which color is which. I'm just telling you, I know you shifted it because I have some information, but I won't reveal it. Does that help, sort of? Cool. What are the superpowers that this unlocks? One is that there's no need to rerun computation. So if you did all the work in your computer doing something, you can submit a proof, and it's going to be very easy for me to verify that that's true. And that's going to be very useful for industry, for blockchain, for other things. And the other very important superpower is like there's no need to see all the information to verify that that's true. So again, like I don't need to see all the information that you had, so I'm convinced that whatever you did is true. What does this unlock? A plethora amount of things, something called proof of X. So I can make a proof that I've actually came here to study at Oxford without telling you which is my student number, without telling you like my degree, etc. I can prove that I'm from Costa Rica, or I can prove that I have KYC, like for financial purposes, with a valid institution, or I can prove that I have a vaccine without telling who am I and giving all my private information. Or I can prove that I've attended an event, or that I'm over 18, or that I have this amount of reputation or credit score. So you see, it's a plethora amount of things that I could prove without giving you any of my personal information, and that's really important. So for privacy reasons, it's super important, but also for scalability. In the computation world, I no longer need to see the whole history of all the transactions that have happened on the blockchain, and I can be convinced that nobody has cheated. So those are some of the examples that exist and that are really important. So zero knowledge helps us achieve privacy, scalability, and interoperability. Those are kind of like 3 other properties. These are not related to the blockchain trilemma, or maybe privacy and scalability are. But yeah. I'm going to give some examples so we can have a bit more of a discussion. We can make a proof of solvency. So how do we know a company is solvent, or an institution or a bank, without revealing all the information? Well, you make a zero knowledge proof that the assets are bigger than the liabilities. We have a project called Anon Adhar, where you prove that you're an Indian citizen without sharing who you are, what's your age, what's your sex, whatever. There's another blockchain called Zcash, when you can have anonymous transactions. So everybody knows that the transaction is valid because the proof verifies that you're not trying to spend more than what you have, but nobody knows what is exactly what you're doing, to whom you're transferring how much money. You can prove that you're a human being and not a like bot. You can vote without revealing who you're voting for, and you can prove as well that you make all the counting correctly. You can authenticate and prove that you can access a website without giving your username or password. We can have decentralized social. There's a bunch of things that we can do with this zero knowledge superpower. And it's great for GDPR too. So in Europe, it's very important. This is like, I forgot what it stands for, but it's basically data regulation. Like companies need to comply to this and need to make sure they're not storing or they're doing good handling of users' information. Well, with zero knowledge, you don't need to. If you are not keeping any of the data yourself and you're just verifying that the people have the right access, maybe you reduce a lot of your risk of doing GDPR. It helps us with scalability because now you can have a very, very big machine. I don't know, imagine like a huge computer doing a lot of calculations. And you can verify it just in a small computer, like in yours. And you can, for example, in the future, we could have a central server, super big, counting votes in the UK, and we can all be convinced that they didn't cheat on the vote counting. And we just verify with our cell phone or our laptop. But there was a huge machine who did all this calculation and then just generated a proof. And that's just one example. There are many, many others like machine learning models, AI, and we can like, I don't know, climate, health, statistics that they can just do a proof and just a smaller computer verify that they did it correctly. There's also the other model in which individuals make proofs, like you and I make a proof of something, and then a central server just verifies. So that reduces a lot the complexity of this central server basically having to do all the work for everyone. These are some examples of projects, especially on the Ethereum ecosystem, that are trying to compress transactions and say these 1,000 transactions are valid, and I'm just going to post a proof. So basically, that what it allows, and then the blockchain just verifies that this is correct. So what this allows is to scale the blockchains without having to have a bigger computer. You just, with a smaller computer, verify that these 1,000 transactions are correct. And that's a clever way to scale without sacrificing decentralization, security, like the trilemma that we were talking before. And another that I'm super excited is interoperability. Is how can I prove that something that is true from one domain and transferring to another? What do I mean by that? Let's say I could prove that I have 1,000 followers in Twitter, and that allows me to enter a specific space, conference, etc. I can prove that I have over X amount of savings on my bank account without telling you how much and without telling you who you are. And there's a bunch of things that you can do with this. I feel like right now we are in the traditional world, Web 2 world, let's call it, a bit like enclosed in our ecosystem, and we cannot leave because we're going to leave a lot of reputation behind us. So let's say in Facebook or in Twitter or in Instagram, maybe you would like to move to another platform because of risk of deplatforming or many others, but you already have social connections there. How do you carry them over to the new platform? Well, Zero Knowledge can help with that. Can say, I own this account and I have this followers or reputation or whatever, and I'm going to port it over to a newer one. And I can make a proof of that. So I feel this is really good to finally untangle and give the opt-out option to users before that before we didn't have as an option. Yes?
So does that, in this case, for the example of followers,
Yeah.
does that require any changes from Twitter side?
No. It doesn't need Twitter's permission. It doesn't need any other additional construction. You can make a proof with the information that they give to you that you control this account, that you have 1,000 followers, and a bunch of other things. So I think that's a great question, because these platforms are not incentivized to let people go. So that's why they would try to make the impossible so that you don't export and take away your data or your information or reputation elsewhere. But with zero knowledge, you have the option, and I think that's the important thing, an opt-out way to carry over, and you're no longer like enclosed. Great question.
Yeah, I'm not an expert, but does that still rely on some third party that like is guarantee that my proof is valid?
Yes. So the protocol itself, how do you say this? With the cryptographic, you can be sure because it's basically like signed. You can imagine like, and I know that it comes from you, or I know that in this case it uses TLS certificates. You can prove that this information actually comes from Twitter or actually comes from somewhere else. Yeah. Yeah. So for example, I will no longer need to take my bank statements and download everything. I can just prove to another bank that I have over this amount of savings, and that would allow me, I don't know, a specific loan. Cool. So just to wrap it up, I think we have like 10 more minutes. Key takeaways. Zero knowledge proofs, that's what CKPs stand for, can be compared to where's Waldo, where's Waldo. It allows you to convince someone else or somebody else without disclosing any specifics, without disclosing information. CKPs, or zero knowledge proofs, play a significant role in privacy, scalability, and interoperability, both for blockchain. And that's kind of like what's been revolutionized in the last year, 2 years, 3 years. And we'll also do that for the Web 2 world, what we call like the industry, the companies that we know more and hear from day to day. This is a field which is largely unexplored, hugely dynamic. And if I were to say, just give some estimates, I feel like it's only like about 1,000 or 1,500 people that actually develop and build things with this right now. So it's still very niche, very, very new, but it's already very promising. And it's already like being on the forefront of a lot of like the research and new cryptography methods and new like systems because of the potential that it has. And that's it. Thank you very much. If you want to follow me on Twitter, I use Twitter or Discord a lot. And yeah, let's just have a nice conversation about these things. Thanks. Cool. Any questions, comments?